Another point to make also is that under acid catalysis, the amine attacks the neutral carbon. What that means is that if you have this, at pH 5, this won't become this, the protonated carbonyl oxygen. This won't happen simply because NH2CH3 is a stronger base. So make sure you're aware of that when you draw the mechanism. So the stronger base will be protonated first, but even at pH 5, it's not protonated as readily. So be aware of that. Do not protonate the carbonyl as part of your mechanism. No, NH2 is going to attack. This is what's going to happen. Not this. Very well. So let's go now to the addition of secondary amines. Notice we have two R groups. So in this case, you have two methyl groups attached to the end. So that's a secondary amine. And we call these enamines. Enamines are the name of the products. And what products you make, they look slightly different. Here's how they look like. So once again, this is a secondary amine. And this is a product. Nope. All right, so there's no double bond between the carbonyl, the former carbonyl carbon, and the nitrogen. Instead, it's a single bond, but you have a double bond between the carbonyl carbon and the methyl that was there. So this is called an enamine. And you probably can understand why it's called an enamine. This is an alkene, and then you have an amine. So the combination is called an enamine. So the mechanism is very similar, at first at least. So the step one is the same as in step one for amine formation. It's the same thing. You may, if you would like, copy it underneath here. So it's this step right here, the formation of the carbinolamine. And then the second step is the dehydration, but it's slightly different. So let's look at it. So basically what happens is that you get to this step right here, where the O was protonated. And then you have the N. With the two methyls attached, or the two R groups. Again, it's very similar. So we also have the protonated amine. Protonated secondary amine. because we need a leaving group. And that leaving group, the OH will be water, a great leaving group. You probably now predict what the next step will be. Once again, you follow really what you did for the last one. So these lone pairs, this lone pair comes down, form a double bond, and then the water is kicked out. Let me bring them down here so we can have more space. By the way, this is a CH3. Let me put them here. From the starting material, from this. So I'm going to draw out the CH3H's because I need to use them. I need to show you a step here. Wait. Yeah, we did that part. Let me just. Very well. Now the next step is, and the last step is, we have a secondary amine. Deprotonate one of the hydrogens. And then a series of steps happens here. These electrons fall down to form a double bond. And then finally, the pi electrons in the double bond go back on nitrogen. So you end up with the CH2 double bond, carbon H, and then NCH3, CH3. And here are the lone pairs. So that's your enamine formation.